And we should be live. Let's see if anyone's listening. And we should be live. Let's see if anyone's listening. Right. All right. Let's see if can I see the chat here? Let's see. I want all the comments. Okay, anyone who can see this? Hey. All right. Let's see if I can change the camera as well. All right. So now you should be able to see my face as well, right? And yeah, sorry for this video quality here. It's an old webcam. I was about to throw it away in the garbage, but I found a use for it right now. So let's see if this works. Right, maybe not the best focus. Okay, so let's wait a minute or two to see if people appear. I should be able to see. Seven viewers. All right. And let's post it here and post it to some friends here. All right. So thank you for showing up to this stream. Wow, we really got a huge plug from the European Ham Radio Show. So yeah, no stress. So what I'm going to talk about today is this thing here. And this is a power amplifier. By the way, does the audio sound okay? Can you hear me fine? Does it clip? Should I increase, decrease the volume? Yeah, please let me know in the chat if you think the audio is okay or bad, or it's okay, right? All right, let's go with that. All right, so this is a kit I bought from eBay. It costs, I don't know, $20-30, so really inexpensive. It's not really a complete kit. You need to bring some stuff of your own. And let me just grab this old Intel heatsink, which I salvaged from a dumpster. So I will use that one as my heatsink. And I might also use this aluminium enclosure. Yeah. But from a discussion from Mastodon, we talked a little bit about these transformers here, how to think about them, and I started to measure the inductance, and some guys at Mastodon wanted to know additional values, so I thought I'd show the process of measuring this. And well, to be honest, I don't really understand how this stuff works, so take what I say with a big grain of salt. But let's see, maybe I can show some schematics or something. I could probably draw something. Let's see. I have some pen and paper here, and let's see if this camera is actually usable. Maybe. Alright. Now this is... Okay, this is not going to be readable. Yeah. Maybe I can just write using this camera here. Yeah, this would probably work. Alright, so the input from your radio goes into a transformer, the input transformer, and it's connected magnetically to well, 2 outputs here, and then you have a bunch of biasing stuff, and well, I'm just going to skip some stuff that maybe doesn't matter for this purpose, but in the end you have a, well, it's something like this. You have a MOSFET here. How do you draw a MOSFET? Something like this. And you have a MOSFET here. And these are arranged in a push-pull configuration. So when the input signal looks like this, this transistor will see this, and this transceiver will see the opposite. And basically this will amplify only the upper half of the signal, and this will amplify the lower half of the signal. So at this point you see something like this, and at this point you see the second half. Well, this should be alright. This is improvised, you know. So yeah, they take turns, so to say. And here at the output you combine these again. So it's something like this. And you have your output here. Right, so there's an input transformer and an output transformer, and you can see them here on this board. Oh, let me see, let me check the chat. Audio only on one channel. Yeah, sorry, this microphone is a bit weird. Yeah, let me not get into the details, but like the left channel is double the volume of the right channel, and I don't know how to fix that, so sorry. Right, if you have to click mono OBS Studio. Yeah, okay, LabCats, thank you. Let's see if I can fix that real quick. Properties, no, okay. Advanced settings, balance mono, okay. Alright. Okay, so everyone with headphones, now you should hear mono. Let's see. Alright, back to this thing. Okay, I should probably remove the paper now because it messes with the exposure. Alright, so here you can see the input transformer. It's one of these binocular cores. It has, it's one piece of ferrite that has 2 holes in it. And this output transformer is actually 2 ferrite tubes, and they are just next to each other. And then, if you can see it right here, there are actually 2 metal tubes that go through these ferrite tubes. So one of the turns in this transformer is just these tubes going that way, and then they are soldered together. Let's see, on this side, and then it goes back to the other tube. So that's one turn, or one half turn that way, one half turn that way. And similarly on the input transformer you have a half turn here with these metal tubes, and then you have the other wire going through multiple turns. So the input transformer has a 2 turns on the secondary here, and our output transformer has 3 turns. So you have the 1:2 ratio and the 1:3 ratio here. So this will transform, let's see, down the impedance on the input to half, or that means 1/4, I think, because it's half squared. And here you will get from 1/9 up to 1. So 50 ohms, 1/9 of that, so that's something like, I don't know, 5 or 6 ohms, right? Right, so, okay, so what are we going to do today? We can start by fetching this lovely inductance meter. So it measures inductance. So we can connect it to something. We could connect it to the primary on this side. And we can read, let's see. I don't know if this is good streaming material at all, by the way. This was just a weird idea I had. Okay, 4 microhenries, it says. So, and yeah, I should probably note that. It's a bit difficult to explain what I'm doing while I'm trying to plan what I'm actually doing. But let's see, we have the input transformer, and we have the wire connection, which is by itself 4.03 microhenries. Okay, I just noted that here, and we could check the half turns of the secondary here. So I'll just hook this up. Let's see. Now we can see 0.54. So tube number 1, 0.55 microhenries, and this half turn here, 0.57. Right, and these two together should be, well, slightly below 1. If I can get this connected. No, maybe not. Resistor. Oh. Did I do something wrong? And now something is acting weird here. Don't get any proper reading. Oh, okay. That's because I measured the inductance on the short circuit side here. So let's see. Yeah, that makes sense. Alright, let's put this into picture as well. And 0.98 microhenries. So, okay, so the tube side has 1 microhenry, and the 2 laps of wire has 4 microhenries. So I guess that makes it like if you double the turns, you double squared the inductance or something like that. I don't remember the formula in my head. Oh, let me check the comments. That's better. Okay. Good evening. That's much better indeed. Yeah, thank you. All right. Have you got to give it 52 volts? I think this is actually meant to be run at 13.8 volts. You know, the 12 volts of amateur radio. Yeah, the kit says it's 70 watts, but you know, I will probably get something between 20 and 50 watts out of it. I want to try to. I want to try to get more than that out of it, because that's what I need, and I also want it to be linear and not cause spurious emissions, which I know that you can't get at 70 watts with this one. Yeah. All right. All right. So that's the input side. Let's measure the output side. Just these opened inductances, and I will show you on the schematic later what I'm doing. All right. So let's go to this chunky side. Okay. So tube number 1 on the output transformer is 2.70 microhenries. Right, in the second tube. .67, and both of them in series should be about double. Alright. Yeah, 5.51. And now the wire, which is 3 turns. So 3 turns seems to make the inductance be 9 times bigger. Let's see. Yeah, 49.14 microhenries. That's the wire. Alright, so I have a table of measurements here. Yeah, let's write some more. Right, some measurements here. And basically what we have done now is to measure the inductance of this and this one, this one, this one, and this one. And if we had an ideal transformer, we should be able to short out, for example, this side here, and that should essentially show up as a short circuit here, if the transformer is ideal, which it isn't. Well, if it isn't ideal, then shorting this side should cancel kind of like most of the inductance here, but not everything. So there will remain some inductance, and I don't remember what this inductance is called. Yeah, please write it in the chat if you remember. Yeah. So an actual transformer might be seen as an ideal transformer with some extra inductance there, which doesn't do any transforming, but is like parasitic or something like that. So I would like to measure how much how much of that inductance we have here. So I'm going to short, let's see, measure here and short this one to this one. So I will try to cancel out both of these, and actually I would try to cancel out one of these in turns and then both of them to see what happens. So how to do this structurally? Input transformer. And let's measure at the wire. And then I need to short these two somehow. Let's use a screwdriver or something like that. This is okay. This is going to be hard, but let's do it anyway. Yeah, okay, we got 4 microhenries here. I don't know if that shows up on the camera at all. Yeah, or it doesn't. And if I short out these two, yeah, this is not a good way to do it. I need something more springy, or maybe crocodile clips. No. Yeah, sorry for the noise. Something conductive, perhaps. Not something too long. Ah, I know. Let's use this solder wick. it's flexible, so I can just push it down with the screwdriver and hopefully it will make contact. Okay, so let's just lay it on top here. Okay, this is not going to be hard. Should probably just solder this across. Oh wait, yeah, this might actually work. Okay, so it went to 3.4. No, it's still readjusting. Yeah, okay, I should figure out a better way to do this. 2 screwdrivers, maybe. Alright. Yeah, I don't know if this works. Now auto timed off. Okay, I'm pushing this harder. Oh, okay. Now the inductance is actually 0.15 microhenries. Cool. So I managed to 0.15. Is that right? Let's just note this here. Let's see. So the inductance was 4 microhenries, but when I shorted the other side of the transformer, only 0.15 remained. So that means that the coupling is probably pretty good. And so that's nice. And let's try something else. Let's try measuring at this side. Okay, we got still 0.5 something, and I should be able to short this. Now I could use this crocodile clip. All right. Yeah, this is okay. This might actually work. Yeah, I think so. Let's see. Okay, the inductance went to 0.30 microhenries. I will probably write this in a table and talk to the guys at Mastodon and see what to actually make sense of this. Yeah. You mean stray inductance? Yeah, stray inductance, that's right. Leakage inductance. Yeah, leakage inductance is probably the correct term for what I'm trying to measure. The coupling coefficient and leakage inductance. So, I think the leakage inductance in this way is 0.32 microhenries. Alright, let's do it here. Alright. .33 microhenries. Okay, and I will do the same on the output. Yeah. So we'll measure at this wire here. Let's see. And I'll try to short the primer here. Let's see if this trick with the solder braid works again. Maybe it does. I don't expect, like right now, for this to be very interesting to watch, I guess. I had a few people in mind who maybe wanted to actually see this, and all the rest of you are welcome to join and enjoy and watch, I guess. I should probably done a better job at explaining what I'm doing here, but well, okay, let's see here. 0.31 microhenries. That's no. So if I, yeah, okay. So I don't know if you can see this. Right now we have about 50 microhenries of inductance, and if we shorted it on the other side of the transformer, let's see if I can do it with a screwdriver here. No, this is okay. And then it went to basically almost 0. So what is 50 divided by 0.3? Well, that's very much lower. So that's cool. Yeah, let's measure. Okay, so this was measuring at the wire, shorting both the tubes, and I will measure tube number 1 and tube number 2 in the same. We'll actually do one measurement which will be interesting, will actually be more interesting than the others, and that is to measure like the two halves of these transformers. Well, the tubes that go through here. On this one, they actually share the same ferrite block, but on this one, this is two separate ferrite blocks, and theoretically, like the one tube here and the one tube here should be very weakly coupled to each other, and yeah, we'll see if we can measure that somehow. Let's check the chat. What if you short only one side? Expect only goes to 25. Okay, yeah, let's actually do that first. Okay, then I need a wire, but that's manageable. Let me get my junk wires here. Something. Maybe this one. No. I'll make myself some wires here. Alright. So try to pinch this so that it doesn't have a lot of loop area, and we'll see how that goes. So now it's 49 microhenries, and let's see if I can short 1/2 of the primary here. Yeah, 25.87. Right. Let's short the other one, and 25.95. Yeah. So half the inductance on the secondary here went away when I shorted, well, half of the primary. So it makes sense, I guess. That's good. All right. Now I'll measure at the primary here. Oh, and primary and secondary the roles are reversed for this one and this one. Maybe I should just say the tube side and the wire side. I don't know. Let's see. How many how many people are still watching? 8. Wow. I was expecting like 3 or something. All right. Okay, so measure again. Let's short the wire side. This, yes, still makes sense. And do I get a good connection here? No. This yellow wire was a bit weird. I thought it was just ordinary wire with plastic on it, but I think this is enamel, because I tried to strip it with a wire stripper, like nothing happened, and I needed to scrape away it with a knife instead. Alright, so okay, we have measure from the tube number 1 side, we short the wire, then we get 1.38 microhenries, and let's check this side. 1.37 ish. Alright. So what do we see here? Okay, so now it's 1.37, 1.39, and if I remove this crocodile clip, it goes to 2.7, I think. Yeah. So it pretty much almost halved. Alright, so now to the interesting parts. We had a bit of discussion at Mastodon if there is a difference between this kind of transformer and this one, because this is the one material and this is 2 pieces of material, and yeah, we should be able to, like on this part here, measure inductance here on that tube through that ferrite, and we short the other one. Let me just prepare notes here. I'll put we measure at tube 1 and we short tube 2. And I should find my wire. Where did I put it? Here. Alright, and if I short the other side, well, basically nothing happens. Yeah, 2.273. Okay, so barely didn't happen anything at all. So that's interesting. So when I short this side doesn't even notice it, and that's actually a good thing, because one of the transistors is connected to this one and one of the other transistor is connected to this one, so the transistor outputs will not see each other. I think they are isolated from each other. That's probably a good thing. Well, there's this question of what happens because they're only conducting for half the cycle. Yeah, how to think about that, I don't know. But that's interesting. Now, what happens with this one? I'm actually curious. Alright, so let's get the solder braid out of the way. Measure input. At tube number 1 by shorting tube number 2. Okay, so originally we have 0.57 microhenries, and if we short the other side here, okay, it doesn't, yeah, nothing happens here too. Okay, so let's test this again. A bit fiddly. 0.55. Okay, so we went down a little bit. So from the measurements I made so far, I don't think I see any difference between this kind of transformer and this one. I haven't fully read the Mastodon thread where this was discussed, so I guess I should go back and do my homework. Let's see, check the chat here. Alright, goodbye. And yeah. Right, so these values, to collect them was what I was going to do. and yeah, I'm pretty much finished with what I try to do here, but yeah, to analyze this and figure out what it means, yeah, that's a later task. So I might as well just talk a little bit about what's the next step for this build. I guess that's more interesting for most people. So let's see, I need to strip these wires here and solder them to these pads. The same for this one. Yeah, this. Okay, the video quality is probably really bad, right? Yeah, because now they are not connected. So I wanted to measure everything first, because when they are soldered in place, like, everything's shorted and you can't measure it separately again without opening it up. So I'm doing that now. And let's see, next up is probably probably mounting the transistors. So as I said before, this will be mounted on this big chunky heatsink here. So I will put it like this, and let me get my bag of components here. The transistors, these two, okay, will go here and here. And then I need to, well, screw them in place into the tapped holes here, and I will solder these pins in place as well. And then there are some feedback resistors. These are resistors that go across the transistor, basically from the output to back to the input. So when the output goes up, it will actually counteract, well, it will work as negative feedback. So well, this will feed back a little bit of signal, and which will lower the gain of the amplifier, but it will make it more stable and nice behavior or something like that. So those will be mounted like over here, I think between well, the big pads here, or maybe the small pad here and here. Yeah, it looks like this pad and this pad, right? And then it's actually probably testable. Also need to add some connectors here, for example these SMA connectors. I would actually like to use BNC connectors, so if I use this enclosure here, I might actually drill some holes and put some cables here to make connectors on the front panel, or I will solder BNC connectors straight to the board. I haven't decided yet, depends on what I have. And I received some new connectors yesterday, so maybe I could use those. Well, we'll see. And when that's built, there is a lot of testing to be remaining. There is a small adjustment potentiometer here. Let's use my left hand so you can see something. Right here. And this will turn up the gate bias. So you want basically the transistors to be right on the verge on being on when the input is silent. So you don't want the signal to have to rise up to a certain level before the transistor opens. You want the transistor to be already pretty much opened, or even slightly conducting. And so you need to adjust that, like find that exact spot when it starts to conduct. Because, well, if you overshoot it a little bit, then both transistors will actually be on at the same time, and you will have a basically short circuit from plus to minus, and you can burn this up. So apparently there are plenty of opportunities to burn up these transistors, and I should probably get myself a bag of them right now so that I have spares, because I expect that to happen, right? And yeah, another thing that's needed, there are actually pads here and here for connecting the signal which goes out here to a low-pass filter and feed that back into here. And you need that to suppress the harmonics. Well, the more linear a amplifier is, the lower the harmonics are anyway, but you will still get some harmonics which you need to take care of. So I also need to build a low-pass filter later. I don't know which order I will do that, if I will do that first and then test it, or if I will test adjusting the gate bias first and then build a low-pass filter. Yeah, let's see. And yeah, after that, that's probably most of the work is probably mechanical, just drilling holes in the enclosure and doing that kind of work, which is hard, and well, but in the end the result looks very, very nice if you have a proper case for it. And yeah, also I didn't explain why I need this in the first place, so let's do that. Let's see if anyone is left here. Alright, some new people actually joined. Hello. So this is my previous build. This is a BitX40. Let's see if I can just enlarge this part of the stream instead. Yeah, let's do something like that. This is a rig for the 40 meter band, which is just 7 watts. It's a kit build also. As you might have known, I don't actually own any working commercial ham radio equipment except for a Baofeng. So I want to build stuff myself, or at least build a kit and understand how it works. Yeah, so this radio is a SSB, like voice radio. And I haven't had much luck with it because it's only up at 7 watts, and it's possible to have contacts with 7 watts, but it's you need the right opportunities. You need people to actually want to talk to you specifically, I think. So I would like to change that by adding this this amplifier to get up to 20 or 50 watts, which I think should be able to change my opportunities so that it makes it much easier to actually be heard by other people. And yeah, I have some success with another amplifier which I have here. This is a kit from QRP Labs. It's their 50 watt amplifier. So why not use this one, you might ask? Well, this is not a linear amplifier. So it's only good for example, Morse code, CW, or FT8, or other digital modes that only send like one frequency at a time. As soon as you have something like voice, which sends a spectrum of frequencies, then those frequencies get, due to the non-linearities of an amplifier like this, they get blended together in weird ways, and well, people can't hear what you say, or in the case of digital modes, well, you can't be decoded. Yeah, so you have to have a linear amplifier, and those are inherently more inefficient, so there will be lower power for the same amount of, well, the amount of power out per amount of power in will be lower, so you need, well, larger heat sinks, fans maybe. We'll see if I can actually run this without a fan at all. Maybe I'll try. For this occasion, well, for this build, I actually bought this thermometer with well, temperature probes, so that I could actually try to measure the temperature like at the transistor to see if it is about to blow up, or yeah, because otherwise I have no idea if it's operating in a safe region or not. Yeah, what else? Yeah, well, I think I'm running out of well, both time and things to say. So, well, thank you all for who are watching right now, and yeah, thank you for being kind guests of my first live stream here on YouTube. It's a bit scary, and well, it was scary at the first 5 minutes, and not that scary anymore. So, well, thank you all for listening, and well, hope to see you soon.